There are obviously several challenges that we know that organizations face when it comes to data. They experience challenges around sourcing data, knowing what's usable, what isn't. There are some great open data sets in the market. However, they may not be maintained, or they may have been developed as a one-off. And as a result, there are significant gaps in modeled energy data, and certainly they lack consistency. There can be complex licensing frameworks and complicated terms and conditions that add to the overall cost of data, as you may need to buy licenses that cover the entire nation, for example, or procure multiple licenses from multiple suppliers. Internal skills, so those key skills internally, are often used to make data usable and integrate that data into your systems and your processes and your workflows, rather than using the skills to gain insights from the data itself. So therefore, a lot of time is essentially spent on build rather than use. And finally, organizations don't really want the hassle of having to store and maintain the data themselves in-house. How are we solving these challenges? We're solving challenges with Net Zero Data. And Net Zero Data is a suite of high-quality data sets currently being used in the market that have been developed by our team, so you don't need to, with a collective 30+ years of experience and expertise underpinning the data sets that we've developed. And that experience sits in data analysis, modeling, spatial analysis, whole systems modeling, and of course, local area energy planning. Our data sets are available either standalone or in bundles for project themes such as renewables and storage, renewable heat, building retrofits, and transport, allowing you to quickly identify potential projects. Net Zero Data covers the whole of GB. However, the data is made available at either the local authority region level or the postcode sector level. So there's some flexibility around how we slice the data. So you only need to buy what's relevant to you in your area, and that goes into supporting the more detailed portfolio analysis and identifying potential market opportunities. Net Zero Data is plug and play. It's ready to use, and that allows you to use your time to get on with developing insights for your customers instead of trying to create the data sets yourself and go down that true bespoke route of building in-house. Net Zero Data is available in accessible file formats, compatible with any GIS or analytics tool. We're completely platform agnostic, so we don't force you down a specific route. We issue regular updates for our data sets, so you don't need to worry about maintenance and updating and dealing with all of that overhead in terms of data and managing data. Our data sets are all available with flexible pricing. You can purchase the data sets with one-off access or with continuous access, by local authority region or by postcode sector. If your end user is a local authority, you're able to leverage public body licensing and discounts. So we've already touched upon the PSGA Ordnance Survey licensing there. Our ready-to-use data sets, they all align to net zero themes. They instantly show you the potential for renewables and storage, potential for heat solutions, potential for transport solutions, and modeled building and energy demand. These insights around the potential for basically mean that you don't have to try and figure it out for yourselves. We've taken that work away from you, and we've done that work for you. So these instantly give you the insights that you need. So in summary, Net Zero Data enables you to save time and resource with ready-to-use data, quickly identify potential projects, quickly discover market opportunities, and purchase regularly updated and maintained data, either by a local authority region or postcode sector. And looking forward, we're always developing, we're continually developing our data product. We're working on new data sets, improving our existing data sets. And obviously, we're keen to hear from you about your challenges, use cases, and needs. So yeah, we'd love to hear from you. So please do reach out. And now we will move on to a demo. In this demo, what we'll do is we'll take a bit of a deep dive into project identification and sort of identifying market opportunities as well. So we've recently been speaking to somebody who wants to identify locations for smaller heat networks where ground source heating solutions for the individual property isn't viable. And this is someone who would need to work with portfolio managers or councils who own their own housing stock. So the first thing I need to try and understand is, what does the lay of the land look like? which properties have high energy demands and aren't suitable for individual property ground source heating solutions. I want to understand which properties have high energy demand, right? So I've pre-filtered this. So this shows me the properties with based on energy demand and property type. So we're focusing on social housing here. And also this second layer that I've just enabled shows me potential for ground source heat pumps. So now these layers combined, they show me social housing with high heat demand and a potential for ground loop heat pump systems. And as you can see, these properties in red, with the bright red dots, don't have potential for ground source heat pumps, likely due to the garden size for a looped installation, because these are tightly, densely packed properties, terraced houses, etc. So now what we can do is start to hone in a little bit further and start to build up a more detailed picture. So now if we start to pull in open network data from the DNO, what we can do here is try and start to understand and give us the ability to determine locations that might be suitable for some of these smaller community heat networks. Right, so looking at what I've presented on screen here, there's plenty of infrastructure around the area, which does have capacity, as well as land adjacent to this pocket of properties here, to the right of that pocket, that could potentially be used as a heat source location, right? For a small heat network to serve a small community or small area, this could be one to put on the list, and therefore allow you to investigate further through engagement with land registry to identify landowners, and determine the viability of installing a small heat network in this area and working with stakeholders to come to that conclusion. But you can use this data to look at multiple areas, or validate or do a first pass initial validation on an area that you've already selected. Now let's take a look at another use case, which focuses on non-domestic interventions and renewables. So we've also been speaking to a renewable technology installer who needs to understand which of their clients' non-domestic buildings within their portfolio would benefit the most from low carbon technologies. For two reasons: one, to lower their carbon footprint, and secondly, to potentially unlock additional revenue from renewable energy through deploying low carbon technology. So the first thing, again, what I need to do is try and understand which buildings in an area are sort of the highest energy users. And what I can do here is enable a data set that shows me the peak demand for non-domestic buildings. And this data can be filtered to specific building uses, for example, retail, community halls, or any other sort of building classification. Or you could filter by energy uses above a certain value. So once you've determined which buildings in your area of interest, you can then start to layer on and take a closer look at potential low carbon technology options, such as rooftop PV. What I'll do is I'll enable this rooftop layer. And what this does is it places dots where the dots align on buildings where there's high energy usage. So the darker buildings are those that have high energy usage, and the little grey dots are buildings that have potential for rooftop solar PV. And where those dots align, you can then really start to sort of home in on the lowest hanging fruit for those interventions for your clients and for their portfolios. So bringing in, as I did with the previous use case, once you start to bring in sort of network data and get a feel for kind of capacity on the network and any other constraints, through that combination of these multiple data sets and layers, you can start to build up a view of where interventions could be placed, and where those interventions can unlock potential revenue through obviously selling energy back to the grid, and also enabling your customers and your clients to achieve their net zero goals through reducing their energy usage, moving to a more renewable framework of technology. Now let's take a look at our final use case, which focuses on a local authority project, specifically around transport. So there's a current project requirement that aligns directly with the Levi Fund. It's a project type that local authorities are working on delivering at the moment. As a consultant working on projects or responses to market tenders of a similar sort of nature, you need to try and understand what a local authority can deliver with a high degree of confidence, whilst also saving them costs throughout the life cycle of the project. And in this use case, we'll look at identifying potential locations for overnight EV hubs. in locations where residents don't have potential for off-street parking and therefore home charging. So first I need to get a view of which properties don't have potential for off-street parking and whether or not there's any existing EV infrastructure in the area. So one of our data sets here shows the potential for off-street parking. So there's a lot of greens and reds. The greens obviously indicate properties that do have potential for off-street parking, and the reds are those that don't. And these are the ones that are of interest, right? These are the ones that we need to, as a local authority, you may need to provision some infrastructure, overnight infrastructure for them to be able to charge overnight and then support their transition to electric vehicles. So let's take a look at existing infrastructure that might be in situ around this area. As you can see, I've just enabled the existing charge points layer and data set, and that shows me that there's one or two charge points in this area, 2 charge points in this area. So there's 25, maybe 30 properties here that are all red that don't have potential for off-street parking. 2 chargers here wouldn't meet the needs if all of those homeowners decided to purchase EVs and move to electric vehicles. That being said, there's also a lot of greens, and we have to consider the choice option as well, right? Residents, although they have off-street parking potential, they may not want to install a home charger. They may not be in a position to transition to an electric vehicle just yet, but it's that choice element that also needs to be factored in. So there's a percentage of residents here who may not want to charge at home if they decide to transition to an electric vehicle. So now we've got this view, we've got an area that we want to sort of focus on. What we can start to do is bring in another data set that we have, which presents the potential for overnight charging hub locations. And as you can see, we've got 2 locations appearing on screen now. So we've got one sort of further to the north and one sort of in the middle of the area in question. And these are hub locations that are within walking distances of properties that don't have potential for off-street parking. And that is one of the requirements of the Levi Fund, is that any overnight charging hub locations have to be within walking distance. So now we've got this view. So, okay, there's 2 potential locations here. One offers more charging potential, the second less. But again, as with the other use cases that I've demonstrated, we can start to bring in some of the open network data, which gives us a view of where the infrastructure is, but also headroom, that can then help you prioritize and understand potential cost implications as well. So if we look at this location here, the closest substations are one up here and then one down here. So from a cabling perspective, this could be quite expensive to provision and get connected up to. However, these 2 substations here seem like the closer distance, they're virtually on site. Costs might be more manageable. However, this data doesn't mean that you don't have to engage with the DNO at any level. This just gives you a means to prioritize. With all of the use cases that I've been through, what I've shown you gives you a means to prioritize.